Hello everyone, I am Emertxe, final year student pursuing Electronics and Communication Engineering in Congo Engineering College at Tamil Nadu. I am pursuing Embedded System Internship at Emertxe in batch number 8, and my project is washing machine. Before getting into my project details, I would like to explain my experience and the knowledge gained through the internship program. The PPT going to cover certain things like four major topics we have covered throughout the internship. First one is C programming, and then about the microcontroller, that is PIC 16, and then tools and peripherals, various tools and peripherals we have learned, and finally we have the project implementation that we have done. Let me start with my PPT presentation. um, yeah, here we go. First, C programming. We have cover in the internship program. I come to know the basics of the C programming, how the C programming has been implemented in embedded projects that I have been gone through. Starting with the basics, where I got introduced with C data types, and what are the basic functions like printf, scanf, and what is the use of inbuilt functions like size and the other sign modifiers. Then comes I have undergone the various condition statements and loops. Condition statements is nothing but if and its family. Its family means it indicates the if and if else, and nested if, so many things, and how to use them. And then comes we got I similar to if I have learned switch cases, and what is the importance of break, continue, and that and all we have learned through the internship. Then comes loops. I have learned many such many loops like for, while, do while, and how to use them efficiently, those things, and how to implement the delay using for loop. All the things I have learned, and some arithmetic and relative operators they have taught us. After conditions and loop, we got with arrays and pointers. um, Arrays and pointers, and how to use them. For CLCD program we have used arrays, and important things, pointers, how to allocate memory, and how to use the pointers, everything, how to dynamically allocate the memory, everything we have gone through. Then comes endians. We have learned two types of endians, big endian and little endians. And other than that, we have gone through the types of pointers: null pointer, void pointer, while pointer, and so on. After covering the arrays and pointers, we have concentrated on functions. In functions we got to know about the different types. One important function is called recursive function. Recursion is nothing but a function calling itself is called a recursive function. The important thing in recursion is base condition. We have to set the base condition, that is when the loop has to end, when the function calling itself has to be end, that is called base condition. Recursion. After recursion function, we come for the last portion called strings. Strings and memory management. In strings we learned various inbuilt various inbuilt keywords for string, like size of, and everything we have learned in the string topic. Then memory management. They have handled the memory management, how memory is classified, how it is classified as OS and kernel OS, and how memory segment has classified as a text segment, stack segment, data segment, heap segment. In text segment, the written programs are stored. In stack, variables are stored. In data segment, there are two types in data segment. One is data segment, another one is BSS, blocks dot BSS. DS is nothing but it stores the initialized variables, whereas uninitialized are stored in BSS. These are the things I have learned in memory segment. And also the heap. In heap is the place where in the memory segment where dynamic memory allocation are done. Other than the memory segments, we have learned the storage classes, such as what are the different types of storage classes: auto local variable, register local variable, and static, and what is global variables, and what is difference between static variable and global variable, and what are how static global variable can be used. And also we come across the keyword called extend, which is used to call the global variables in different files. Not only this, after the memory segment, we gone through the pre-processors. Pre-processor is nothing but how to write the header files for specific use, how to define the preprocessor, and how to define the header files, all the things we have learned in the C module. After C module, we have jumped into the embedded programming. The embedded programming, we have started with the introduction to microcontroller. The controller we are using is PIC16F877A. It is a PIC which comes under which is a 8-bit controller, and it has a 10-bit ADC. There are 8 channels of ADC, and we have the internal picture of the PIC16F877A. You can see the timer 1, timer 0, timer 1, timer 2, or the 3 timers we have. We also have 10-bit ADC through 8 channels we have, and CCP 1 and 2 we have, and also we have PWM enable PWM. It also support various communication modes such as USART, SPI, and I2C, which all are shown here. We have various type of timers: power up timer, oscillator startup timer, watchdog timer, brownout timer, in circuit debugger, and many timers we have. And we have 5 ports: port A, port B, port C, and port D, and port E. Each have port B, C, D all having 8 pins, and port A having only 6 pins, and port E having only 3 pins. These are it has its own built-in ROM, RAM, everything it has. Yes, it's a microcontroller, so it's compulsory. And the operating speed of PIC16F is 20 megahertz. This is the basic things about PIC16F. Then to implement the project, we have used some tools and softwares. MPLab X IDE version 5.35, the latest version of MPLab. I use this to code my C programming, embedded C programming, in which I can build and I can correct the error, and I can convert my C programming into a hex file. And then comes a PICSIM lab app. The PICSIM lab app is a virtual software, virtual app where I can virtually do my project of with the PIC. The output of the page, or the page of the PICSIM lab is shown in the picture, where I have various features like fan, buzzer, and CLCD display, and various buzzers, and digital keypad. PIC, this is the PIC IC I have, and various resistors, and various adjustment buttons we have. This is the area where I implemented the washing machine program. Then comes the peripherals. We have undergone different types of peripherals. One such peripheral is CLCD. This is the connection of CLCD with PIC16. Of course, we are using this PICSIM lab, we have we have the CLCD connected, we have the same CLCD connected with this PIC through the internal settings. But if we are connecting it manually, we have to connect these things. It has a data bit of 0 to 7, that is, it has 8 data pins, and VSS and VCC for ground and power run. Then this VD is for connected with potentiometer. This is nothing but to increase the intensity of the LCD or decrease the intensity to adjust just. R and S it and R W bar is read and write bar. If we want to read from LCD or write, enable is the output. E is nothing but an enable pin to enable the output in LCD. And we have anode and cathode for LEDs too. It is basically 16 cross 2 LCD we are using. 16 cross 2 means 16 is nothing but the column count and the 2 is the row. It can have it has 2 rows and 16 columns. In our MC lab, we have the option to switch from 16 cross 2 into 16 cross 4, that is 16 columns and 2 rows, and 16 columns with 4 rows. Both option we had used 16 cross 4 option in our project. We come to know that afterwards. Then we have various functions like put ch and print. Put ch is used to put only one character, and the print is to print multiple lines in the LCD. And another thing we have to remember is we can only able to print ASCII values. Even if we want to print any integers or numbers, we have to convert them into ASCII, then only we have to print. After this CLCD, the main thing is timer. Yes, in our project we have to concentrate more on timer delay generation. We have, as I said earlier, there are 3 types of timers in PIC-C. That is timer 0, timer 1 and timer 2. We are using timer 2 for our project. Before knowing about how to configure the timer, let's see the basic concepts of timer. Here the basic concepts of timer. Timer is a 8-bit register, which is nothing but it can have 255 ticks. If 8-bit means 2 power 8 is 256, that is from 0 to 255 it can have 255 ticks. What is tick means? From 0 to 1 if it changes means that is 1 tick. 1 to 2 it changes means it is another tick. So likewise from 0 to 256 the 8-bit timer register can have totally 256 ticks, and the quantum is nothing but the duration taken for 1 tick. That is from changing to change from 0 to 1 it taking 200 nanoseconds. To generate, as we know how timer works, timer has to generate interrupt, then only it means it has count 1. 1 means it's not 1 second, it's to just count 1 it has to undergo overflow in the interrupt. In the case of timer, in the case of PIC16F, we have 4 cycles to generate one instruction cycle to 2 instruction cycle. For 1 instruction cycle we have 4 for 1 instruction cycle we have to undergo 4 counts, which is nothing, one timer. Sorry for interrupt. For 1 duration of tick we have to undergo 1 instruction cycle. 1 instruction cycle is nothing but 4 clock pulses. 1 clock pulse is inversely proportional to frequency of the peak. If the frequency, as we said earlier, a frequency of the peak is 20 megahertz. So the clock pulse is inverse of 1 1 by 20 megahertz. Therefore, duration of one tick is 4 into 1 divided by 20 megahertz, nothing but 200 nanoseconds. This is how the quantum number has been arrived. To generate one interrupt, the formula is 200 nanoseconds, that is quantum into number of ticks, that is nothing but 51 microseconds. That is every 51.2 microseconds the interrupt has been generated in timers. We can adjust this number by using the scaling factors, that is prescale and postscale. Prescale is done by changing the instruction cycle, whereas postscale is depends on overflow. If 1:2 is the prescale, means we have 1 is tick and 2 is instruction cycle. For 2 instruction cycle, 1 tick has been implemented. That is the meaning of 1:2 prescale. Similar wise, if we use overflow, means that is postscale. Here the important part of the timer, how to count our own 1 second. Because why I have taken 1 second means we have to count our time in seconds and minutes only. To count 1 second, what is the formula is time is equal to number of ticks into quantum into count into scale. That is nothing but number of ticks is 256, quantum value is 200, and the count, if we count 20,000 times the tick, if we count 20,000 times, means we can arrive the value of 1.02 second. That is we can inversely study that to count 1.02 seconds we have to count 20,000 times. These are the basics of timers I have learned through the intern. Here the procedure for timer to delay generation. To calculate the timer count, we have to set the prescaler or postscaler in T2 con register, and then we have to load the timer in TMR2 register, and we have to enable the timer to interrupt, that is TMR2 2IE register. And after enabling the timer to interrupt register, we have to enable two interrupt register GIE and PIE by assigning the value to GIE and PIE, that is global interrupt and peripheral interrupt. Then we have to start the timer to by setting the bit TMR2 timer to on. If we set the timer to on bit, means it starts to count in the ratio of what we have set in the prescale. Then an important part is digital keypad. Here we have 4x4 digital keypad, that is 16 keys with 4 rows and 4 columns. It uses 8 pins with row and columns. It requires pull up and pull down resistors. These are the common digital keypad we can come across in ATMs and automation and wherever we see in many places like ATMs. It works good with Arduino, PIC, ESP32 everywhere. We have the Pixim app have the inbuilt digital keypad which we have used in the project. Here after learning the basics of C programming, the basic embedded concepts, we have gone through many peripherals such as LED, digital keypad and CLCD, timers, everything. And after learning all the basics, we have successfully implemented a washing machine simulation. The project, washing machine project includes many features such as power on, washing program, that is nothing but here we have multiple washing programs I will show in the demo, and water level or low level, high level that we used to come across in our washing machines at home, and start and stop programs, the timers, the display and door open allowed, the important thing in washing machine. Every features we have included in our project. Okay, that's about the journey of my intern and my learnings. I have missed I would maybe I have missed some learnings. However, I will show my project demo here. This is the Pixim Lab app I was speaking about. I have spoken about. Let us imagine the screen as a washing machine LCD display, and we have the washing machine buttons are here. RB01 is first button. This is B1 is second button. B2 is third button, and this is fourth, fifth, sixth, and seventh button. We have 7 buttons. We are not going to use everything. Let me explain it while I am programming. And this fan we have, and buzzer we have. The fan is to indicating the rotation of motor. We have using the fan, and the sound to produce the sound we are using the buzzers. And let me show you the output of my demo. Let me reload the hex file. Here, to start with, we have to press key 5 to power on the washing machine. RB4 is the 5th key. I am pressing that. The washing machine is powered on. After powering on, we are entering into the washing program. We have many washing programs. I'll show you the demo. To down click, we have to press the 4th button. We have daily, heavy, dedicates, whites, stain, eco cottons, woolens, bed sheets, rinse, dry only, wash only, aqua store. Totally we have 13 options. We can select any one of the option. Let me choose heavy or delicates. Let me choose delicates. To select the program, I have to long press the same 4th key. Let me long press. After long press, I came to the water level screen, where there are many water levels. Low, there are 4 water levels: auto, low, high, and max. Let's have high water level. To select, we have to long press the same key. Okay, here it's showing the operation. Here the operation going to begin. We have to press switch 5 to start, and we have to press 6 to stop. Let me show the stop first. If I press the 6th key, stop, it goes against to the washing program, and I have to come again through the same long press and auto. Now I am giving the start. After giving the washing machine is gonna run for 25 seconds. We can stop by passing we can stop the program by pressing the 6th button. Here I have stopped the 6th button, and the rotation of the fan is stopped, which indicates that the washing machine has stopped. The function, the time is we didn't give any time, random time. We have gone through the set of data given by our mentor Guhapriya. According to that, for every wash, for every cycles, we have the timer, and the timer has been splitted for washing, spinning, and rinsing. All the times it has been the time has been splitted in certain ratio for washing, spinning, and rinsing. Let me show this. To start this, again I have to press 5. For some seconds it has been in the wash mode, and now it has been turned into spin mode. After spin, I think we have delegates nothing to rinse. We have selected that program, so it shows only wash and spin. Let me show the another program. Let me choose daily. And I am choosing water level as high, and I am gonna press the button 5 to start, and it's totally 45 minutes it's gonna function. First begin with wash function, and to show the interrupt we have included switch 1 as a door openings interrupt. If I press button 1, which indicates door is open, please close, and to alert the user we have turned on the buzzers alarm until the door is open, that is until the button 1 is pressed, the alarm gonna to sound. After releasing the button only, the program gonna resume again, and that's all. It has come from wash to spin. We can have the start and pass buttons. After spin, it may go to rinse if the program has set in that way. In the same program we don't have the rinse, so after completing the timer we are come to this point, program is completed, remove the clothes, and again after removing clothes we come to the initial position. This is how project works well. We can have various programs and water levels. Every program is working well. That's it. Thank you for your patient listening, and thank you Emertxe for wonderful learning opportunity. Thank you.